All right. So what can we do now? What do you think the approach is now?
Let's see. Well, there's some relation between z and this equation here, because you have r plus s over 2 equals negative b over 2, and you have some of the same parts here. You have the b over 2 is the same. You can probably get this r over 2 in here.
Yeah.
There's some relation between z and s and negative z and r.
Yeah, and this is, we said if their average is this number, then one's got to be a little bit above, one's got to be a little bit below. So this came from this equation here. Do you have any guess?
Well, I'd put it back into this equation and see what happens. Now that we have a form that may not lead us in a circle.
Okay. You put it back into the top equation.
Yeah, because you put r into the equation, see what you get. You put s into the equation, see what you get. And you know those have to be equal because they're both 0.
Okay. Any other ideas?
You could put them into these equations here.
So you could put them into this because
Or,
this.
oh, you
this-
haven't used this.
This was what was used, so that may help you.
Okay, why might that be interesting?
Well, you haven't used this equation to create these equations.
Right,
so-
that's a new equation.
Yeah.
And we would like to try to see if we could solve for z. And why is multiplying r and s maybe not that difficult?
Because this is just the difference of squares equation. It's both halves.
It's a difference of squares equation. This is something plus z, and this is something minus z. It's the same thing minus z.
Yeah.
So when I multiply r times s, and I may or may not be able to write this through the camera, r times s, what is that going to equal?
B squared over 4 minus z squared.
Okay, b squared over 4 minus z squared, and that equals
This equals c.
Sorry if this is a little light to read. And that means z that we're trying to solve for, z squared equals b squared over 4 minus c. So
Okay.
z is plus or minus the square root of b squared over 4 minus c.
C.
And remember r was negative b over 2 plus z. So we'll say plus b squared over 4 minus c. And s was negative b over 2 minus
Yep.
b squared over 4 minus c. And now we actually have an expression for r and s just in terms of the constants.
Huh. All right. Well.
Does this match what the quadratic formula would say?
It's similar, definitely. You have this over 2 and the over 4 inside the square root, but it's definitely similar.
Yeah, it matches it when you have the 1 coefficient, which you have here, because you just get a common denominator on the inside of the square root, and then it just turns into b squared minus c, or b squared minus 4c over 2.
Yeah, so this if I get a common denominator on the inside, I get negative b plus or minus the square root of b squared minus 4c all over 2. Because I have a b over 2 here, and then that 4 is going to... Do you see how that 4... When I put it on the top, I get the 4c, and then I have a square root of 4 on the bottom, which just becomes 2.
Right.
So there we go. So let's get it. Now what I want to do is go through the whole derivation in general, putting an a out in front. All right?
Okay.